Hi everyone, I'm Julia Heider, Senior Editor with Modern Machine Shop, and I'm your moderator for today's webinar, which is sponsored by KUKA Robotics. Today's machine shops face many challenges, including finding and retaining qualified personnel, cost pressures, delivery pressures, quality issues, and lack of available time to learn and implement new technologies. Robotics promises to address some of these challenges, but this technology has a reputation for being well suited for larger companies, which have engineering staff that can implement these technologies. Smaller shops with low volume, high mix production are often left out. KUKA Robotics partner Waybo recognized the unmet needs of these shops and developed standard automation products that specifically address low volume, high mix production and can be used by anyone on the shop floor. Today's presenters are Waybo owner Jean-Sébastien Neveu and KUKA Robotics Canada's Vice President of Sales Jarek Niedbala. You can submit questions for our presenters at any time during the presentation using the Q&A tab on the right, and we'll answer as many as we can at the end. I also wanted to let everyone know that this webinar is being recorded and attendees will receive a link to the recording via email. So with that, let's get the presentation started.
Thank you, Julia. And thank you, Jean-Sébastien, for being here with us today. I mean, you're the expert on machine tool automation, and we're glad to have you here because that's what the topic of today's webinar is. And I'd like to start off by mentioning that I read recently that the average machine tool that has not been automated cuts only approximately 25% of the time in a full day. Would you agree with this statement? Does that make sense to you?
Hi, Eric. I'm glad to be here too. Getting less than 30% of spindle time is very common in the shop. So most of the shop run their machine on one shift only, and the efficiency of the operator is not 100%. So to give you an example of calculation, based on 24 hours, if you are running your shop on one shift and the efficiency of your employee is about 80%, it gives us less than 27%. So yes, I'll say your sentence is correct.
Okay.
So, but to have a general idea of the audiences, let's do a quick poll. I'm questioning myself, guys. Have you ever calculated the efficiency of your machine shop based on 24-hour period?
Yeah, and we would really highly encourage the audience to participate, just to give us a vote of yes or no, just to get a bit of an insight into what's the reality in your shop. So highly encouraged if you can participate. Appreciate it.
So yeah, we're getting result. Yeah, okay, fine. So 66% of the people answer no at this point. So
yeah, so the majority definitely. Yeah, and quite frankly, without making any calculations, but just by knowing how much labor costs and capital and opportunity costs, that's 75% of non-cutting time seems to represent a lot of money lost, doesn't it?
You're right. We lost a lot of money by running our shop on 25%. And machine shop can easily increase its efficiency of their CNCs up to 80% of spindle time with automation. At least many of my customers reach quickly 50%.
Okay, so, but if machine shops can achieve this type of efficiency and save all that money, I mean, it seems like a no-brainer to automate. And yet, why is it that some machine shops still have not automated their machine tools?
It's a good question. In the past few years, we have seen a lot of shops automate their CNC. It's more than more. But I was still asking myself, why so much are not? So I interview many of my customers analyzed the information and found that the major concern to not automate the shop, the people think that the technology is too much complex. It's too much complicated. They also don't have any dedicated people to manage an automation project, to bring a new technology in the shop. Most of the time, the owner of the shop will manage the project, but they already have the shop to manage. So you don't have enough time.
Yeah, and especially these days with how difficult it is to find labor, it becomes even more difficult, doesn't it?
You're right. The other point that come often, it's about they don't have any qualified personnel inside the shop to program and maintain the automation. It's come. Many people told me that, and the most common one, it's about people told me that they don't have an appropriate production to put an automation. This one I hear it a lot, many times. But let's just figure what's mean low volume, high mix. It's the reality of many shop, and I base my product on that. The things that we must consider is it's not the number of parts we have to produce, because they have a difference between the number of parts and the total production times. I mean, if we have only, I made an example of that. So let's say we have 30 parts to do only. It's not a big amount of parts, but if it took 15 minutes per part to do, we have a shift production long. So that's perfect to put a robot. That's mean at the end of the day, you can start the automation to produce on the night shift, and the next morning production is done.
Yeah, that really does make sense, Jean-Sébastien. So in addition to these concerns, are there any other ones that customers have expressed to you?
Yes, one's coming. I hear a lot, but it's not related directly with the automation, but automation can fix it. It's about the planning in the shop. So I mean, can we accurately predict how many pieces we will do tomorrow, or how many pieces we will produce the day after? So I would like to bring a new poll about that, if you want, guys. Can you predict accurately how many manual loaded parts you can produce in a day? That's a good one, and I hear a lot of time people do the same part number on today and tomorrow. Today they will produce 30, tomorrow they will produce 45, the day after 20. So it's very non-consistent.
Yeah, and once again, if we could have the audience participate, just a simple yes or no would really help us get some insight into your reality. So much appreciated.
Yeah, interesting. We're getting about the same result. So more than 60% of the audiences have some difficulty to predict that. So that's good.
Yeah, it's quite common, isn't it? So now, but going back to the list of concerns, Jean-Sébastien, are there any additional ones other than the ones that you have listed so far that we should be aware of?
Yes, of course. The cost is one, and the delivery time, it's another one. So how much it is, and when it will be in production. So those two are common too, of course.
Absolutely, yeah. So definitely it's a list of concerns that any small to medium machine shop would have. Absolutely. And yet I know that you have helped some very small machine shops. In fact, I remember there's one machine shop that had, I think, 4 machine tools run by a couple of guys, and yet that they embraced automation thanks to you. Can you tell us a little bit more about that?
Yes, to start a product, to bring a new product on the market, we must find what is the needs, and I found 4 key foundation points to develop automation for small and medium enterprise. One of the most important one is the product must be standard. First, it's an important key. It's reduce the risk. We don't need engineering to add on that, and the deployment is really fast. So that one is it's a major one. Number 2, the operator must be able to use it easily, and if I have many of them, it should be the same interface. So a common and easy to use interface, it's very, very important.
Yep, that makes sense.
Third one, the autonomy from the integrator. Once we installed a system and train your guys in your shop, you must not be tied with us, with the integrator. So the customer, the machine shop must get autonomy from the integrator and be able to redo a new setup, reprogram the units, start production, change over every days. It's really important. And the next one is the last one. Sorry, guys. It's about remote support. So we need to be able to remotely support you quick and fast. So I don't need to send my guys on site or some of my partner on site to help you. We can connect, help, and support directly from our shop. So it's helpful.
Okay, so basically, even though the shop has become autonomous, they still have that safety line that remotely you can access the machine and get the information, get them going if they get stuck on something.
Yeah, some quick question. Where is this function? Or I don't remember where I should press. So I can see the screen if they'll give me the access, and then I can help them and guide them. And with those 4 key foundation points, in the past 10 years, we developed several standard products based on that. And here's an overview of those standard one. Some of them are on my right behind me on my back, but on the screen you can see all of those. Well, we'll pass over later on the presentation.
Yeah, those are some very nice looking machines. As you know, KUKA, we tend to really focus on form and function. So we have some nice looking robots, but I think that you have also followed that kind of ideology, because those are some smart looking machines for sure. And so, Jean-Sébastien, can you tell us a little bit more about how a machine shop owner could prepare for automation? What kind of steps they need to take in order to have a successful adoption of automation?
It's a good one. Where to start? What should we do first? My recommendation, first, we must select the right machine to automate. So it can be either an existing one that you have on your floor. It can be a brand new one that you want to buy. Also, if you want to buy a new, we can assist you to make sure you purchase the right option on the machine. So the choice of the machine is very important. The machine must be accurate, a good one, and reliable, because now with the automation in front of your machine, Usually you use it maybe on one shift, but then you will step to 2 or 3 shifts. So the machine will run 3 times more. So it must be a good one to choose.
So Jean-Sébastien, understood, but what if it's your best machine? However, currently it's at, maybe 30% capacity. You just don't necessarily have enough projects for that machine. What's your recommendation at that point?
Can you repeat the question?
Yeah, let's say that you have the best machine, right? Most accurate, most reliable machine, but currently that machine is not necessarily the one that's used the most. You know what I mean?
Yeah. Got it.
Would you pick another machine, or would you still recommend going with that machine?
Yeah, sometimes it's hard to change production from one machine to another one. The CNC program is done, the work holding is done, but at the end, if you can move your production from another machine to the automated one, yes, you will need to manipulate your NC programs or the way you manage your production, but with the robot in front, you will be able to produce so more. So I will recommend to move your production as much as you can to the automated one.
Oh, I see. Okay. So you still basically use that machine. Got it.
Yeah. Or buy 2 systems, man. It's up to you. Next one, we must determine. We need to know what is the range of your parts. Is that usually big part, small part? I know it's hard to predict because most of the time you don't know what you will produce next weeks or next month. But if we have an idea about the size and the weight, I mean, is that lower than 5 kilogram, between 5 and 15, or more than 15? It will help us to guide us on which of automation product is more appropriate for you. Because the way it's worked, the robot have a limited payload capacity, and it must be considered when you do your choice. But like you see on my back, I have a 10 kilogram payload robot, a 20 kilogram payload robot. I have a 70 kilogram payload robot right there. So you need to choose which one is the best for you. Mm-hmm. And also, before making any buy, we must figure when it will be, the payback will come, the rentability of the investment. So it's another thing that I can help you guys with, because we develop, it's not perfect, but it's the easiest way to predict the ROI of your investment. And I made a quick example table to show you right there. So let's say we buy an automation solution for $150,000, and then maybe you have to modify your CNC a bit or not. Maybe you need to bring the electricity and pneumatic supply. I figure $10,000 for both of them. So let's say the total project is $160,000. Then depending where you are located, you may have access to a tax credit. So in some places it's 5-10%. Some of them are 40% for any innovation. So you can get up to 8. I don't know. It depends where you are, but I heard about 40%. So this is a huge one. And based on 2-shift production day, with an employee shift cost about $45,000 per year average, with an efficiency of 85%, because nothing's perfect, we calculate that in less than 2 years, you reach your rentability, and then your machine can run for the next 10, 15, 20 years. So it's good. It's a good ROI, I think. So the payback calculation is important. Other thing that may upgrade this payback, it's what else can you do with the robot when the robot is waiting after the CNC? Because we some of the time we had some process on the side, such as inspection, marking, or cleaning of your parts. So those one are common.
Yeah, not only that, but I guess by adding some post-processing, you're actually improving that ROI, aren't you?
Yeah, exactly.
Okay. Now, tell me a little bit more about that post-processing. How does that work with standard machines, which is what we're talking about here? How is that post-processing added? Is it by Waybo? Is it by someone else?
Uh,
Can you add an
I can
example?
show you an example. Right there, it's a setup we did a couple of years ago. Customer have already delayed, so then they buy from us standard solution such as the cyber drawers, and they also buy a CMM, a Zeiss CMM inspection machine.
Mm-hmm.
So then we integrate it in our system. So the robot put the raw material, put it on the CNC. When the cycle is done, some of the time the robot flip the parts to do the OP20, then remove the parts from the CNC and then bring it to the CMM to do the inspection, measuring, validate the tolerances, and then depending of how it's connected to your CNC, the CMM can give directly the offset for your tool on your CNC to correct your cutting. And then after that, the robot, when the measuring is done, the robot can take it from the CMM and put it back on the outfeed systems and flag it depending of the result. If it's a good part, it will be green. If it's a bad part, it will be red. So the operator will see, oh, that one may be wrong. So you must look at that.
Well, that becomes very useful, especially if you're doing a lights out operation, I guess, right?
Of course, because on very, very tight tolerances on your parts, it's hard to let your machine run for 8 hours, all night shift without feedback, depending of your process. But I can show you also the real pictures of what it's look like. So you can see here it's a DMG Mori lathe plus Zeiss Duramax and our drawer systems.
Mm-hmm.
So it's quite compact in front of the machine, and also the customer had by himself a cleaning station. I didn't do that. The customer integrated by himself after I left. So
that's, I guess, an example of how customers can become autonomous to the point of actually taking your cell and modifying it, adding more value, getting more out of it, right?
Yeah, without always depending on us.
That's really good. That's great. So, Jean-Sébastien, you mentioned to us, a list of concerns that small to medium machine tool owners could have, and the 4 key foundation points that you use to develop solutions for them, as well as the steps that you would recommend that a machine shop owner would take, to prepare for embracing automation. But what about Waybo? How do you fit into this? How can you help small, medium machine tool shops?
We are specialists on that. We only do CNC machine tending. So all of our standard product are based on those 4 foundation points. We only do that 24/7, so we know the reality. We know what is it to be a machinist, to put parts on the CNC, to manage the chip, the coolant, the chip bin, how tight can be the tolerancy when you put the parts inside of the chuck, or a collet chuck, by example. So we understand that, and I think it's a value thing that we can bring to you. And as you can see on the pictures, it was pictures of my shop a couple of weeks ago with all those equipment in the inventory also. So we duplicate it and make sure the delivery is very, very short. But let's pass through quickly on our solution. Actually, we have 6 of them that we made often. They can work for lathe or milling application. Both can work. Some of them are working only on 120 volts. So you plug it in the wall and you're ready to start. Most of them are on 480 volt also. We have standard solution for parts feeding or pallets feeding, depending of what you're doing. So we have software to help you to feed your CNC with a pallet system also, if you don't want to use part by part, depending of your production. Standard solution for parts up to 40 kJ, pallet system are up to 350 kJ. Version with or without fencing also, depending of your application. If you don't want to have a physical fence, we have other variation for you. You can buy a shop manager. Our solution can have a shop manager, so you can manage your production, task scheduler, remote viewer or notification also. It's good to receive an email or notification to tell you that, hey, I need new parts, or hey, the machine have something's wrong. You should came and look at that.
Yeah, that's excellent. You know, I think the pictures are great, but I think it would be great to see some of these products in action. Do you happen to have any videos to share with us?
Of course, I have, yes. Here we see a drawer systems with installed on the side of the DMG 5-axis machine. It's a DMU80. Then the cyber drawer works. We have 4 drawers of material. Robot can pull himself the drawers on his side, or the operator can have access to the other one on the other side without interrupting the production. Mm-hmm. Then this example shows the system on the side of the CNC, but it's also possible to put the machine on the front of the automation on the front of the CNC. It's always depend of your CNC and your layout. Then we have a single vise inside, but we have option to bring maybe 1, 2, 3, or 4 vices inside, depending on how many operation we have to do. Because we are managing also a way to flip the parts. So we are not only doing operation 10, we're making sure that we are able to flip the parts and then do the second operation and maybe the third operation, because the goal is to get a finished part the next morning when you come back to your shop and make sure you don't have something else to do on the parts.
Right, that makes sense. So Jean-Sébastien, in addition to offering standard products, I imagine that you also offer some services or some way to basically accompany the machine shop owner in their journey towards automation.
Yes, we offering a complete turnkey solution. It starts from the beginning, you're thinking to add it, up to your production is running. In detail, what does mean? We are helping you on your choice. Which standard solution is the best for your application and your machine? Which tooling your robot must have to hold the parts and manage your process, and which kind of accessory we should add to the machine, such as maybe a flip station we name it a rig grip station, but to flip the parts and put it back to do the second operation inside of the CNC. Then after that, we are helping you, and we are doing for you, if you want to, the integration. So we guide you about your processes changes. So what need to be had on your NC program, by example, how we will communicate with your CNC, do you already have the auto door, or you need us to bring you one? Because we have it too. So if you need auto door, we can supply it for you. Other interesting point is the installation. It's not a couple of days or weeks. It's less than 2 days. So it's very quick and easy to deploy.
Yeah, that definitely is something that I guess a standard solution can only achieve, because typically an integration of a robot and any kind of machine, requires engineering, requires safety analysis and all these other things. And typically you're looking at weeks instead of days, let alone 1 to 2 days. That's really quick.
Exact. And most of the time, my customer don't know what they will produce next week. So if it's take 3 weeks to install, the production is already gone. So that's no point. It's why it's need to be really quick and easy. Mm-hmm. Then other really important points, we are taking care about the safety. So we are making sure that the new equipment you bring in your shop is safe for your operator, but it's also safe for your equipment. That's an important one.
So safe for your equipment, what does exactly mean? I mean, are you talking about some kind of a way of preventing collisions, or?
Yeah, exactly. We are creating an envelope around the robot, the automation, that it would be impossible for the robot to pass away that envelope. So it's quite important. It will avoid any collision with the machine, and or worse, your CNC controller or something like that. So we are taking care of that part for you.
Okay, so basically making it foolproof. That's great.
Yeah. Then we train your guys. We offering with our solution a 3 days of training on site, and it's not just a general training. The training is based on putting in production your parts with your guys. In fact, we are guiding your employee to start the production. So we are not starting it. Your employee do that. So it's a good way to learn it, how it's work.
So basically, the return on investment starts basically right after the training, or maybe even during the training.
Yeah, in less than a week, you're ready to produce, and your guys are trained. Also, came the support. It's important to support you. It may be on site or remotely. Both can work, depending on your needs. Just quick phone calls. I don't remember that, or can you connect? I have an issue with that. So we are able to support you. And finally, with that, we get success and the production.
Great. Well, thank you very much for the overview, Jean-Sébastien, of what you currently offer. But what if we take a look, a little bit of a view towards the future, right? I mean, you're basically in this world, you know what's going on. What kind of trends, what kind of technologies are you seeing that we're going to expect in the future to become, sort of the default for, especially for small to medium machine shops? Because obviously here we're talking about typically low volume, high mix production. What do you see out there?
I'm glad you asked that, Jarek. I'm actively working on a new product that I think that it's the future. And let me introduce you. The next things for me, it's the robot will be able to move from machine to another. So the robot himself will be able to be on an AGV and move from different machines. So maybe 1, 2, 3, 4, 5, 6 CNCs, and then inspection, and then marking, and then washing. So we'll be able to create a kind of production line, but the robot will move by himself between those equipment.
Well, it's interesting, Jean-Sebastien. I mean, I have seen robots move, but typically it's on a linear slide, and so the machines need to be perfectly aligned, and that's it. Those are the only machines that the robot can service. But what you're talking about over here is you could have one machine on one corner of the shop and then another machine that seldom gets used on a completely different portion of the plant, and yet this device could actually service both machines, right?
Yeah, robot, rail. I hear about that every day, almost. And the mobile solution on AGV is so more flexible. A robot on rail, all machine need to be aligned. Machine needs to be almost the same shape. If you add more machine extending the rail, it's not easy to. Or if you change your brand of machine, or the new machine, new design come, and then the shape is not the same, you are not able to align that with the rail. It different. Depend of what you're doing, but most of the time, getting a unit on a mobile platform like that, avoid all of that. So it's possible to move around and translation, go fast forward, and yeah.
So let me ask you this though. I mean, this device uses, I'm sure, batteries, and these batteries need to be recharged. So at some point, you're gonna have to stop it and plug it in into the socket, I guess, to kind of get it going again. So how much time are you basically losing in production while the robot is being recharged?
Good question. Every test we did with that gave us between 8 to 10 hours of autonomy of the unit. So that's
shift.
good. Yeah, about a shift long without needed to be recharged, depending of what you're doing exactly with the robot. But recharging it from zero takes only less than 2 hours. So it's not a big deal. But what you can also add is we can have a charging plate on the ground, on the floor. So when the robot, and let's say we put it in front of your CNC. So when the robot is moving close to the CNC to tend it, to put the part on it, the unit can be recharged at this point. So we can have multiple stations like that on your floor. So the unit will be able to recharge himself every time. So basically, it will never stop.
Yes. So, and because this is, I guess, lithium-ion batteries, therefore fast charge. So you're basically doing micro charges on a regular basis. So keeping that battery at whatever 80% or so. Interesting. What about let's say safety? I mean, typically, you have robots in cages. Here, you basically have a robot that's running around. How do I avoid running into people that are walking on the shop floor?
It's important.
I think so.
All the units are equipped with safety area scanner. So anything close to the unit will make this guy stop. And they have multiple zones that you can program. So it can just slow down more, and then stop. So the unit himself is safe. And when we do the integration in your shop, we are making sure we're taking care of any blind spot when you bring your machine close to your CNC to avoid any collision about safety.
Mm-hmm. Okay.
Other things, we are using those sensors also when the platform itself is moving to navigate around obstacle, such as maybe a guy let a chair or a cart in the middle of the normal path. So the platform can automatically move a bit away and then continue and return to the normal path.
Okay, so basically looking at obstacle avoidance routines, huh?
Yeah, exactly.
Interesting. Now, you've got a robot, you've got a platform. I mean, how do you even go about programming something like this?
Yeah, it looked like complex, but our job at Waybo is to make sure that it's not complex for the end user. Okay. So it's why we develop an interface like you see on the side of the screen. We name it WMS, Waybo Manager Software. With this screen, we have access on all the machine linked to the systems. What is the actual status of them? Where is the platform actually? Where is going? Is the robot is moving? What is the next job you need to produce? So our software to control it, avoid any, you don't need to reprogram it by the way.
Well, that's definitely very cool, Jean-Sébastien. Thank you for sharing that vision of the future for us. I think right now, I think we are ready to maybe wrap up the presentation and see if there's any questions that the audience may have for you.
All right, thank you, Jean-Sébastien and Jarek. It looks like we're starting to get some questions, but there's still time to submit questions if you haven't already. You can do that using the Q&A tab at the right of your screen, and we'll do our best to get to it. If we aren't able to, someone can follow up with you via email. Okay, our first question. We're seeing more and more cobots at trade shows. So when would you use a cobot versus an industrial robot in a machine shop?
It's a great one. Cobot versus industrial robot. I prepared a slide for that. I was sure that it will came. Industrial robot or cobot robot. It's always depend on the application. It's depend what you're doing with the robot. What are you manipulating? What is the environment? Is that someone working close or it's empty? Or how fast you need to go to follow your production? So the difference between both is really the application will help us to decide which one will be the best. Let's on that slide that I'm showing you now. Both solutions have the same payload. So both of them are about 10 kilogram payload robot. One of them is the left one is a cobot. The right one is an industrial one. One of the things it's important to consider when you do your choice of automation, if you choose to integrate a cobot first because you heard that it's easy to program and so on, you need to think where you want to go with your shop. And I name it the technological choice. So you must find the right solution to give you the possibility to manipulate all the parts you have in your shop to standardize your automation solution in your shop. I mean,
doesn't this go back to your 4 key points, your 4 key fundamental points where you want to have a common interface throughout your
easy to use? Yeah, exactly. You're right, Jarek. I have many customers who start with a 10 kilogram payload. It's cheaper. It's easy to integrate, smaller, simpler. Then they move to a 20 kilogram payload because they have a more biggest part. And then, I have a lathe on the back of the shop that must be 10 too. And then they need a 70 kilogram payload robot. So because steel pieces can be heavier fastly. So at some point, the cobot are limited about payload right when you start thinking of that. So choosing the right technology to make you able to integrate it on all your processes in your shop with the same interface. It's very important.
Mm-hmm.
Okay, next question. How easy is the Waybo cell to move from one machine to another?
Moving the robot between different machines. That is another thing that I hear all the time. That is possible. Everything is possible. That is recommended. I'll say it need to be. We need to look at it seriously. When you move your robot between two machines, at this particular moment, you have three machines down every time. The machine where it was, the robot himself, and then the machine where it's going. So your downtime can be quickly rise, and then your rentability decrease right there. So the things that my customer told me all the time is put your robot in front of your best machine and make sure that one run at least 20 hours a day.
Mm-hmm.
All right. Next question. So we just talked about switching the cell from one machine to another. What about switching from one part to another? How long does that take?
It's a good question. The changeover, all of our solution, the changeover, it's less than 2 hours. I have customer who just call me, hey, it's take me 45 minutes that time because it's not his first time he's running it. But a brand new program, a brand new part you never did, maybe an hour and a half, you should be able to do that. If you already did the part a month ago and you just want to restart it, it can take 15, 30 minutes maximum.
Okay. Have you had applications which incorporated an end-of-arm scanning system for feature confirmation instead of a CMM?
I personally don't, but I know many brands do that, like a vision system to see if the part is right. It's something doable, no problems. Just need to be sure. What's look your parts when you take it out of the CNC? Is that oily? Is that many chips on that? We probably must clean it. And then if you add a vision system inside of your shop, you need to make sure that your shop environment is not so oily or dusty. You know what I mean? So because your lens must be clean, light must be bright, and so on.
All right. Makes sense. Next question. Is there an artificial intelligence component in programming your mobile robot or stationary solution?
That will be awesome. Not yet, but I think it's the subject of the hour, the week. So yeah, why not? We'll figure it out.
All right, I have one more question here. So if anybody else has something they want to ask, make sure to get it in as quickly as possible. But unless we receive anything else, our last question is, do robots have a difficult time getting parts with tight tolerances to locate on precision fixtures and plugs, or to get parts on and off?
I personally choose KUKA on my system because KUKA robots are really accurate. It's about the repeatability of the system. It's about 0.02 millimeters, so they are quite precise. And addition to that, we developed some way to make sure that, by example, let's say first up we put the raw material in the vise. Not an issue. It's easy. Everybody can do that. But then when you need to flip the parts and relocate it precisely, because you have a chamfer to do all around, and the chamfer must be perfect and tolerances. So yeah, we can do that. We flip it, relocate that, use the accuracy of the robot, and then we had some value about compensation to make sure that we are at the perfect spot.
Okay, we've gotten a few more questions in, so I will run through these.
Yep.
What is the typical stroke for the grippers, i.e. can I go from a 4-inch diameter part to an 8-inch diameter part without changing grippers?
Yeah, just to make sure we are using the same lexical, we are never changing the grippers, but we are changing the fingers on the gripper. It's like your jaw in your vices. So passing from 4 to 8, we have some grippers that may adapt to that, but it's always depend of the weight of your parts, the materials, many feature, but we also develop some adjustable fingers. So for any standard shape such as square, round, octagonal, we have fingers that we can adjust. So remove the screw, adjust, put it back, then you're ready to go. So it avoid a lot of work holding changing.
Okay. Next question. I know your system is used for CNC machine cells. Would you be able to apply this to a plastic injection molding machine tending?
Yeah. That process must be evaluated too. Some of the time, those type of process are quite quick, and some of the time the part can be big in volume, so we will need to manage how often we need to remove the parts, if we need to deburr the plastic or cut the excedent, and where we will drop the finished part, depending of the size of the part.
All right. We've reached our last question again. So yeah, if there's anything else, we still have some more time. So if you have another question that you want answered, get it in now. But for now, the last question is, have you created an ROI calculator to provide a quick breakdown on ROI for a typical machine shop?
Yeah, and the person asked also if I integrate cycle time, labor rate, shift use or not, and so on. So yeah, the example that I shown on the beginning of the presentation can help us to understand. I did not integrate all of those features, but on that, the calculation is based on the cost of the employees, the operator, and how many production shift and the efficiency. We can go deeper on that to be really precise, but we will need to probably add many things about the tool, how many tools you save, because operator change tool many often. When you put a robot, you will see that you will not use all those tools ever on the machine. Then it's a saving cost. Then how big your company will grow with this new offer. It's another point that it's hard to evaluate because you will increase your capability as a machine shop with that. So those one are more complex. It's why I'm always based on employee cost, production shift, and it's at least it's the worst case. So it can be better than that.
All right, we got one more question in. So if it takes 2 hours to program the robot from one part to another, is it possible to program the robot on a PC to speed up the process?
Yes, the answer is yes. But you will say I say 2 hours to be more. Honestly, it can be really lower than that. It's just to be more realistic. To be honest with you, the first time your guy will program it, it can take the half of the day because it's a learning curve at some point. But after a couple of days, weeks, an hour and a half, it can be done. To answer to your question, if we can remotely program it, the thing we can do, it's coming soon with the new version of our interface. You will be able to pre-program the sequences of the step. So yeah, a part of the job you will be able to do a part of the job offline before.
All right, it looks like that's all we have today. I want to thank Jean-Sebastien, Yarrick, Waybo, and KUKA Robotics for making this webinar possible. And thank you to everyone for listening in. You should receive an email with a link to the recording soon. Thank you for your time and enjoy the rest of your day.
Thank you.
Industrial intelligence.